All right, and we're live. Good afternoon, everybody. Good evening. Welcome into another live stream. This is Dr. Andrew coming at you with another live stream. Today is Thursday, October 30th. And we're going to wait just a few minutes for folks to chime into the chat. Let's get that poll active here. Let's do only 20 minutes on the clock today. And that's going to be what's the topic we should focus on today. Jackson, welcome in. Good to see you. 20 minutes on the clock starting right about now. Go. And so, poll is active. Chat, I'm running out of ideas. Sometimes I feel inspired to do Gen Chem or OChem, but yeah, I'm not sure what we should focus on. I know a lot of people are doing addition reactions, so maybe we'll jump into that. All right, we got our first vote today for Gen Chem. Jackson, what would you like to work on, my friend? We basically can do stoichiometry, thermodynamics, Hess's law, equilibrium reactions. BP, Diamond, welcome in. Diamond says B, organic chem. Make sure you tap on the top left hand side. Tina, Leslie, welcome in. Good to see y'all. We are just getting started today. We got 19 minutes on the clock for our poll today. What topic should we focus on today? We're going to go on live for about 50 minutes today. Another quick one. Another quick live today just to keep it rolling. Hello, Carl. How's it going? Met the great Ryan. Good to see y'all. Cider, welcome in. Guys, as you can see, we are going live every single week, Monday through Thursday, right around this time at 6 o'clock p.m. PST or 9 o'clock EST to answer your STEM questions. I'm going to wait 3.5 more minutes before we fully get started today, so make sure you vote on the top left-hand side of your screen here. The question is, what should we work on today? Make sure you tap the top poll on the left-hand side. Is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? And make sure you let me know what topic we should do. Ooh, Leslie says calculus today. Ooh, we got one vote for each. It seems like we're going to have some competition here. All right, and what we should do is let me know what topics, guys, my friends. What topics should we see? Andros, good to see you. Got another vote for organic chem and AP Calc. Alistair. All right, we got 2 votes for calculus. All right, Shaw, welcome in. Guys, how's everyone doing? We're going to wait 2.5 more minutes before we get started. If you're new here, welcome into the chat. Guys, how's the semester going for y'all? This is going to be our last live stream for the week. Okay, but we are going to have Discord office hours tomorrow. So if you voted, what would you like to go over? Okay, what topics are you going over? Are you doing AP Calc? Are you doing AP Physics? Are you doing college calculus, college physics? Nor, good to see you, says general chem, general chemistry. All right, we got 2 votes for Gen Chem, 2 votes for calculus. Very interesting. All right, 2 more minutes and then we'll get started right away. 2 more minutes and then we'll get started. So make sure you vote, make sure you tap the screen and invite your friends to the live so that they can vote and we can do the problems that you guys want. Do you want to do practice problems today or different topics? Redox equations. All right, redox equations. Crystal says organic chem. Redox equations. Keep voting, chat. Make sure you vote and make sure you invite your friends. Let me get my book for redox. All right, and I'm back. Okay, so we got 9 folks in the chat. I'm gonna wait 1 more minute before we get started. Organic chemistry. How long are you gonna be alive? Only 45 minutes today. Only 45 minutes today. Not gonna be a super long live today. Okay. But we're gonna do our best. Okay, 1 more minute before you get started, chat. We're gonna get started in 1 more minute. So make sure you tap the poll on the left-hand side of the top of your screen if you haven't already. Let's see how we're doing. Let's see how we're doing. Got 15 minutes left on the clock. Okay, let's see how's the poll. All right, right now Gen Chem is cooking with 3 votes, OChem only 2, Physics 2, Calculus 2. So right now Gen Chem is the winner if that's what we're going to be focusing on today. So make sure you keep voting. So I think that's going to be the first topic. We're going to get started in just a few seconds. And let's go ahead and get started now so that we can jump right into it. I think we're going to get started with Gen Chem. But before we do, quick introduction. My friends, welcome into the chat. Welcome into another live stream. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, comment the word new so that we know that you're new. Okay, if you've never seen this live stream before, comment new and we'll welcome you in. And if you've been here before, comment that lock emoji because you know we are so locked in. So get off your phone, get off your bed, get out your notes, and actually follow along because today we're going over your very own STEM questions. Carl says new. Major is chemical engineering, me as well. Jackson is locked in. Luna is new, welcome in. Leslie is locked in. Got some fellow chemical engineers in the chat. My friends, my name is Andrew, and guys, my PhD is in chemical engineering. So if you need help with chemi as well, I got you, my friends. Guys, I go live every single week, Monday through Thursday, right around this time. That's 6 o'clock p.m. PST or 9 o'clock p.m. EST to answer your questions Monday through Thursday. You can ask me anything related to STEM, including physics, general chemistry, organic chemistry, calculus, and engineering. And if you need any help, I got you. Go to my link in bio, go to engineeringminds.co. You can book a tutoring session. So I got you on all those STEM classes that I mentioned earlier. The first session is totally free. You can explore tutoring plans, explore resources, and last but not least, join the Discord. The Discord is a 100% free community where you can join in, ask questions, and interact with other STEM majors, engineers, and future doctors. All right, and then also here's where you can drop in your questions here. So just click on that link that says TikTok Q&A. Let's tap that now. So this is going to be the best place for you to drop in your questions here. And click Get Started. Just select the subject that you need help on. And select the file. Click the link that says Choose File. You can upload your homework directly and I'll get back to you as soon as possible. Either during the live, so you can drop them in right now, or on the Discord, again, that's totally free. And last but not least, guys, once again, I got you on various STEM subjects. So if you need tutoring for math, if you need tutoring for trig, AP Calc, Pre-Calculus, Calculus 1, 2, and 3, AP Chemistry, General Chemistry, College Chemistry, Organic Chemistry, Physics, Calculus-based Physics, MCAT help, preparing for grad school, or engineering, you can book a free session by tapping that link in the bio. All right, guys, we're going to go ahead and get started for today. The first request was Redox. So the first topic, guys, once again, the poll is still active. You got 12 and a half minutes left on the clock. 12 and a half minutes to select your result. What topic should we focus on? Okay, so at the moment, Gen Chem is still cooking. Calculus is cooking as well. So maybe we'll do calculus. So make sure you tap the top left-hand side of your screen and drop down your comment below of which topic you would like to do. Best bet is for you to join the Discord. That way I can see your question ahead of time. But the first question I saw was redox reactions. So once again, get off your bed and stop scrolling and get out your notes and actually follow along. If the first topic is going to be redox reactions from general chemistry. If this is a good topic, go ahead and drop a thumbs up or a fire emoji to let me know that redox is a good topic to start off. Okay, so if you want to learn about redox, go ahead and drop a thumbs up or that fire emoji. And let me know what particular questions you have about redox reactions here. So the first question I have for you is, what is a redox reaction? Rockstar, welcome into the chat. How you doing? Okay, no says I do not miss redox, so we're gonna get locked in for redox reactions here. Again, make sure you vote in the poll. And guys, what is a redox reaction? What is that gonna be? What is a redox reaction? What does that even mean? Okay, redox reactions. What does that mean, chat? We're gonna try to make this as simple as possible, but also still try to learn. Okay, let's get this out here. So who can give me the definition of redox? Let's get these equations out. simple redox. Okay, let's do 123. All right, oxidation, reduction, perfect. So, okay, oxidation and reduction. Okay, so what is oxidation and what is reduction? So what is the definition of oxidation and what is the definition of reduction? Okay, so changes the state. All right, cool, good start, good start. Okay, but what exactly is redox? Just want to get that out here. So what exactly is that going to be here? So redox, oxidation means we're going to use the formula oil rig, okay? We're going to do oil rig. Have you heard of oil rig? Oil rig, okay? So oil means oxidation, okay? Oil means oxidation. There's also Leo goes gur, but I like oil rig. So oxidation, lose electrons. Oxidation is lose electrons, okay? Lose electrons. Okay, there's also Leo gur, but I like oil rig. And then reduction is gain electrons. Okay, so gain electrons is reduction. All right, so if something is losing electrons, that's going to be oxidation. If something is gaining electrons, that's going to be reduction. Okay, so now let's do some examples here. So the person that asked about oxidation reduction, what questions do you have here? What questions do you have about these types of reactions? So let's go over the table here. Let's go ahead and start by defining the oxidation states. Okay, so for instance, we need to define the oxidation states, okay, and oxidation numbers, okay? So for instance, I'm going to give you a reaction here. Let's say I have CH4, let's say I have this reaction here, all right? So let's say I have the following reaction. Leo gur is better. Are you doing just basics? I can do anything, my friend. I can do, if you want to do basics or we want to do advanced, but whoever asked about redox, just let me know. Okay, and then 2Na solid plus Cl2 gas reacts to form 2NaCl. Okay, do you do mathematics? Yes, I do. Okay, so here's our reaction here for our sodium chloride. However, sometimes the transfer occurs in more formal sense. Okay, so rather let's do this one. Okay, let's do this one. So let's do Na solid here. Okay, so all solids, and we have to do the oxidation states. So can someone tell me all the oxidation states of each of these here? Okay, can someone tell me what are the oxidation states of each of these compounds here that you see, each of the elements here? So let's start with sodium solid. What is the oxidation of sodium? What is the oxidation of sodium? Molly, thank you for the follow. Love this. Wish I still had chem. Okay, so sodium is what and Cl2 gas is what here? How do we do this? Okay, so any element, any solid and naturally occurring diatomic elements, so elements and diatomics, solid elements and diatomic gases, their oxidation states are 0. Their oxidation states are 0. So I'm going to put a +0 on the solid here and the Cl2 gas. That is +0. There we go. Luna, there you go. Isn't an element by itself 0? There you go. Okay. You were right the first time. It's +0. +0 for Na and then +0 for Cl2. All right. But what about on the right-hand side? Okay. What about on NaCl? Okay. What about on NaCl? Well, for that, we're going to basically get out our periodic table. And then we're going to see Na is going to be living right over here. So this column, oh, maybe I'm a little bit too zoomed in today. Okay. This column on the left-hand side here is our Na+. This is our first column. So this group represents our +1 state here. And then this group is going to be +2. Okay, so we see where sodium lives, right? So sodium lives right over here. So on the right-hand side, sodium is going to be +1 and Na is going to be +1 and Cl is going to be -1. Now, is this a reduction or oxidation? Is this a reduction or oxidation? Remember, oxidation is losing electrons and reduction is gaining electrons. So which of these gained electrons, chat? Which of these gained electrons? Which of these lost electrons? Okay. Okay. So which of these became oxidized and which of these became reduced here? So remember, oxidation is losing electrons and reduction is gaining electrons. In about 5 minutes, we're going to turn this into a game. So as a matter of fact, let me pull up the poll. Let me see if the poll is overwhelming one topic, excuse me, or the other. So Cl gained, Na lost, Cl gained. All right, perfect. So Cl gained an electron, right? Y'all are doing great. So Cl gained an electron, right? Does everyone understand that Cl gained, Na lost? So therefore, which one is oxidized? Okay, perfect. So and somebody says Na is oxidized because it's losing electrons. Okay, it's getting oxidized, so it's losing electrons, and therefore, so this is going to be oxidized here, oxidized, and then therefore our Cl2 is going to be reduced. Okay, is everyone understanding that so far? We got 4 minutes left on the clock, by the way. So if everyone is understanding that, go ahead and drop a thumbs up down below here. Okay, we got 4 minutes left in the poll, my friends. Make sure you vote on the top left. We still got 3 votes for Gen Chem and 3 votes for physics. Okay, go ahead and drop a thumbs up if you're understanding this so far. Okay, go ahead and drop a thumbs up if you're understanding this regarding oxidation reduction. Will that be an ionic bond? Yes, it will be. Alex says thumbs up. Let's Dallas, thank you for the follow. Just got here, welcome in. Can you do Charles Law? Absolutely. We got another row for Gen Chem. Make sure you vote on the top left hand side of your screen. Okay, I'm gonna keep it going. Let's do another one. Let's do another one here. Let's do another example. We're going over redox reactions here, which again, redox stands for oxidation reduction. Okay, oxidation comes from oil rig, or Leo goes grr. Oxidation is lose electrons. We did our first example, so Na was oxidized, Cl was reduced. All right, so we're going to do another example here. So this one's going to be slightly harder here. We're going to do CH4. We're going to do CH4, okay, plus 2 O2 gas, plus 2 O2 gas. Okay, and then I'm going to make this a gas. All right, so now we have to add up all of these. We have to add up all of these. And we got to see which one's getting oxidized and which one is getting reduced here. Okay, we got to see which one is getting oxidized and which one is getting reduced. Okay, so we have CH4 gas plus 2 O2 gas. So what shall we do first here? What shall we do first? What's going to be the oxidation state that you want to go over first? Okay, remember the solid elements and the diatomic gases are all going to be plus 0. Wait, it's Dallas. Oh, it's Dallas. Thank you for the roses. Thank you for the roses. We got Charles Law and Le Chatelier's. Okay, next up we'll do Charles Law and then we'll do Le Chatelier's, but make sure you vote on the top left hand side. Learning about oxidation, oxidoreductases in biochem. Oh my gosh, that's gonna be a tongue twister for sure. You can also submit questions on the website. Thanks, Jackson. Dear Diary, thank you for the follow. Guys, which one is going to be plus 0? Remember, all elements and diatomic gases are plus 0. So O2 gas is a diatomic gas, so that's going to be plus 0. Okay, so that's going to be plus 0 here. So that's our first one. Now, what do we do for CH4? What do we do for CH4 here? There you go. Luna, shouts out Luna, got C minus 4. Very good. So Luna, how do you get minus 4 for C? Minus 4 for C. And then plus 1 times 4 is a plus 4. Okay, for the H's. Very good. And awesome. So now we got to go to the right-hand side now. So the left-hand side, we have a plus 4 on the carbon and then plus 1 on each of the H's. Okay. And so next we got to go to the right-hand side. Before we do, we only got 60 seconds left on the clock for the poll, my friends. So make sure you vote on the top left-hand side of your screen What topic shall we focus on today? We have 30 seconds left, so let's answer this poll in the next 30 seconds. Vote on the top left-hand side of your screen. Do you want to do A, general chem, B, organic chem, C, physics, or D, calculus? Only 20 seconds left. We got 5 for gen chem, 3 for ochem, 2 for physics, and 3 for calculus. Only 10 seconds left on the clock, my friends, so make sure you invite your friends and sign up on the poll. And it seems like Gen Chem got 5 seconds left. 4, 3, 2, 1. Okay, so it seems like Gen Chem cooked today, and organic chemistry was a close second. Ooh, calculus was doing good at first, but then it got overrun by organic chem. So we're gonna keep it going with the redox, and then we're gonna switch it back to, we're gonna do some more Gen Chem after this. And great, so we have CH4 here is a -4 plus 4, okay? On the right-hand side here, oxygen is going to be minus what? Oxygen is going to be how much, chat here? Oxygen is going to be basically -2. -2 times 2 is -4. And then therefore our carbon is +4. All right? So you have to memorize those oxidation numbers, but the easy way is to just pull up your periodic table and look at whatever column it is. Okay, so that's how I know that oxygen is going to be over here. Okay, 1, 2, so that's -2. Similarly, for this oxygen on the right hand side, that's going to be our oxygen is -2, and then we have +1, +2. So let's see what happened here. Okay, which one got oxidized and which one got reduced? So let's do a quick poll. Let's do a quick poll. So do you think that okay, we're gonna do a poll here. So guys, bear with me as I pull up this poll real quick. So I'm gonna ask you which one got oxidized and which one got reduced. So this is going to be our first question poll today. Kai, thank you for sharing the live. And let me go ahead and bring this up so it's not totally dead space here. There we go. So here's our reaction. And here's our CH4 gas. All right. So this is going to be which one got oxidized? Oxidized. So is it gonna be carbon? Okay. Or is it gonna be oxygen? Okay. Is it gonna be carbon or oxygen? So in this reaction here, which one got oxidized? Do you think it's gonna be carbon? You're gonna vote for a happy face emoji. If you think it's gonna be oxygen, you're gonna vote for a crying emoji. Based on those oxidation numbers here, 60 seconds on the clock, starting right about now. 60 seconds on the clock starting now. So which of these got oxidized? Was it carbon that got oxidized or oxygen that got oxidized here? So we have methane gas, which remember, carbon started as a -4 here. Carbon started as a -4. And then it became what? Then it became what? Okay. Okay. And then oxygen started at +0, and then it became what here? Okay. Another somebody says happy. Luna says happy. Rockstar says happy. And Alex says happy. So far everyone is saying that carbon is the one that got oxidized, which implies that, excuse me, our oxygen is getting reduced. So who's going to agree? Who's going to disagree? Subby, oxidation reduction. Alex, okay, we got 5 votes for happy face. 3 seconds left. 2, 1. All right, we got 5 votes for happy face and 1 vote for emoji. So remember the definition, one for crying. So the definition of oxidation reduction is as follows. Let's hide this. Remember, oxidation means we're losing electrons, and reduction means we're gaining electrons here. So our initial oxidation state for carbon was a -4. Why? Because we had to balance that out for our H here. So we went from -4 to, on the right hand side, now our carbon became a +4. So it got way less electrons. So it lost electrons. So therefore it was oxidized. So if you said carbon was correct, carbon was oxidized, then go ahead and drop a thumbs up, party emoji. If you said that carbon was oxidized, go ahead and drop some thumbs up and party emojis down in the chat. Okay, and that's going to be our basic introduction for redox reactions. Okay. What do you think the hardest chem unit is? Probably thermodynamics is probably the hardest in my opinion. Always get confused between the plus and the minus. Okay, so guys, next question. Should we do the same topic or a different topic for Gen Chem? So let's do a quick poll. So I'm seeing a lot of, you know what, we'll do that in a little bit. We're gonna do that in a little bit. Let's do another example here. Okay, so someone said, I'm getting still a lot of requests for the oxidation here. So now we're gonna take it one step further. We're gonna balance this reaction here. So guys, let me know who's taking Gen Chem right now. If you're taking Gen Chem right now, say me, Gen Chem, AP Chem, College Chem. I want to know if you're in Gen Chem or AP Chem. Are you in college chemistry or AP chemistry? Right now, I'm going to give you a college level problem here, okay? We're going to do a college level example, but I promise you I'm going to break it down so it's not that bad. So whether you're in AP Chem or Honors Chem or Gen Chem, everyone here is going to understand. But the only promise you have to make, chat, is you have to lock in, okay? So if you're actually taking Gen Chem right now, get off your bed, stop scrolling on your bed, and actually follow along here. Okay, I see Subby's AP Chem, Alex says me. Okay, lots of chem here. Okay, and Gen Chem one I will drew and says college. So we got a healthy mix of college and AP Chem. So again, we're gonna do a basic college chem example, but I promise you it won't be that hard. Okay, so if you're in college or high school, this is going to make sense for you here. Now we have to balance this here. Okay, we have to balance. We're gonna do the, let's see, I'm gonna do the half reduction. I'm gonna do the half reaction method. Let me give you another reaction, chat. Apologies. I'm gonna give you another reaction. I'm gonna give you another reaction here, and this one's gonna be the half reaction method here. Okay, let's see if I can have, this one's gonna be better here. Yeah, this one's gonna be better. We're gonna balance. This one should be good. Let me see if I can find it. Here we go. Okay, we're gonna do half reaction method. So guys, again, if you are in AP Chem or Gen Chem, this is going to be helpful, trust me. Okay, so this is going to be the half reaction method, and I'm going to do my best to break it down as easy as possible. Okay, we can definitely do ice tables and equilibrium very soon. Organic chem in college. Okay, and so the next topic, the next example here I'm going to give you is the following. So let's say I give you this here, Ce4 plus, okay, and this is going to be aqueous plus SN2 plus aqueous, and this is going to be Ce3 plus aqueous. And guys, we're going to do the half reaction method here, so actually try to follow along and let me know what your thoughts are at each step. Okay, we're going to break this down and explain it step by step here. So we have Ce4 plus, which is an aqueous, and SN2 plus aqueous. So we have to balance this. So instead of balancing like the traditional stoichiometry method, we're going to balance the actual charges. So right now, let me know if everyone can see that. This is Ce4 plus, SN2 plus, okay? Pretend this is an actual lecture, guys, okay? I do have a PhD, so if you follow along, I promise that this is actually going to help you understand the content. So SN4 plus aqueous here. All right, so we're going to separate this into two half reactions. This is called the half reaction method. Okay, so think of it like this. I'm going to combine my first half as just the Ce, okay? And then I'm going to do the second half as just the Sn here, okay? And then we're going to combine those together to balance it. So instead of balancing the actual atoms, we're going to balance the charges. And so I got to go quickly here because it's already 6:40 my time. So I'm going to say Ce4 plus aqueous. Okay, that's my blue part. Okay, yields Ce3 plus aqueous, right? All right. So, okay, and that's my blue part here. Okay, let me do a quick pause here if everyone is following along here. So if you're still following along, you're not totally lost yet, go ahead and drop that thumbs up here. Okay, if you're still following along, can't see the left part, what about now? Okay, if you're not confused yet and you're still making sense, go ahead and drop that thumbs up emoji. Let's make sure we're all on the same page, because there's one where we add like the OH. Exactly, we're going to be doing that here. We're going to add some water, we're going to add some OH. Okay, we're doing Gen Chem for now. All right, Luna says good, good. Nora says good. All right, cool. Then let's keep it going. Let's go a little bit faster. We have SN2 plus aqueous. And right now, again, I'm not doing anything. I'm just dividing it up. Okay, so step one, divide it up into 2 half reactions. This is going to be required when you're doing your redox chapters in Gen Chem. All right, so here's what we got to do. Okay, here's what we got to do. Oh no, chat. Hold on a second. I keep giving you guys some bad examples. My apologies. Okay, let's see if we can do it from here. My apologies, chat. I keep giving you the wrong examples. All right. My apologies, chat. I need to start over one final time. My apologies. Okay, that was going to be another one. We might try that another time. I'm going to do one more time. My apologies, okay? So we're going to do this reaction here. So this is the one I meant to balance here. MnO4 minus here. Got to go quickly now. Okay, this is an aqueous solution. Okay, plus Fe2 plus aqueous. And then this is going to be Fe3 plus, okay, aqueous. Okay, we got to bring that down. There we go. And Mn2 plus aqueous. There we go, chat. So I'm going to quickly do this. Again, I'm going to separate this out. For my first part is MnO4 minus, and that's going to be Mn2 plus, and Fe2 plus, and Fe3 plus. Here we go. So let's start with the MnO4 minus. So the first one was MnO4 minus, That's going to be basically going to have Mn2 plus here. Okay. And we also are going to have, let's leave some space here so we can analyze the charges. Okay, so here's our example. We have Fe2 plus, and then we're going to react to form Fe3 plus here. Okay. Thank you for the love, my friends. We just hit 1.9K likes today, 6 new followers. Let's keep it going. Now, we got to balance the half reactions. So let's start with this first one here. Okay. So I got to start with this first one here. The first thing I'm going to do is I got to make sure that my manganese here is balanced. So now notice that my manganese is typically going to be involving permanganate here. So my oxygen is going to be -2. Okay, -2 times 4 is -8. So what number does my manganese have to be here to be a total of -1? This is the charges that everyone's confusing here. So -2 times 4 is -8. So what number does my Mn have to be here? There you go. Luna got it. +7. Okay, good job. So +7. Okay, +7 minus 8 equals -1. So I'm just going to write that down to make sure everyone gets that here. Okay, if you're getting this so far, drop another thumbs up. If you're understanding how I got -1 here, +7 minus 8 equals -1. And therefore, this is going to be +2 here. Obviously, this is just +2. So if you got that so far, so good. Go ahead and drop that thumbs up. Okay. Now, I'm going to add water. Okay, I'm going to add water. Okay, I'm going to add H2O. And so, am I going to add it to the left-hand side or the right-hand side? Am I going to add water to the left or the right? Well, notice that I have MnO4 minus and then Mn2 plus here. Okay, I got to add it to the balance that does not, I got to balance out oxygen on the side that does not have water. There you go. So I got to add water here. All right, so I got to add water. And how many do I got to add, Chad? How many do I have to add here? Because I have MnO4. So I only have H2O1. So how many waters do I need here? Okay, we got to add it to the right here because I already have oxygen here, but I'm going to add water. So how many do I need to add? There you go, 4. Okay, everyone's cooking that up. Let me take a pause here. So if everyone's understanding this so far so good, go ahead and drop that thumbs up here if we're so far so good still here. Okay, it's MnO4 minus Mn2 plus here, 4 H2O. Okay, we got 4 H2O. Okay, are we so far so good here? Okay, next we got to balance the charges here. So notice that we have a minus overall 1 and a plus 2. So I'm going to add we got to balance out the H's here. Okay, we got to balance out the H's. So how many do I have to add here? So I have 8 H's here. How many do I need on the left-hand side? So if I have 4 H2O, how many H's on the left-hand side do I need to balance this? How many H's do I need on the left-hand side, chat? Okay, I have there you go. So 8, okay? Luna's cooking today. Luna's cooking. 8 H plus MnO4 minus, okay? So everyone's saying 8, okay? So we need 8 because we have 4 times H2, that's going to be 8. And then we're going to do plus, and then we're going to do plus. Now we have to balance the charges here, okay? So overall, I have, and I can add electrons, okay? So I can add electrons here. So I have 8 plus here, minus 1. So effectively, let me bring down my second reaction down on the bottom here. So now we balance the H's, we balance the oxygen, we balance the Mn, and now we have to balance the charges. So the overall charge, I have plus 8 minus 1 equals plus 2. So overall, I can add electrons. So overall, I'm going to get plus 7, okay, equals minus 2. So how many electrons do I need to add, and which one do I got added to the left-hand side or the right-hand side? Okay, and then how many do I need to add? Okay, if I got plus 7 on the left and minus 2 on the right, how many electrons do I need to add so I can balance that out here? Okay, how many electrons? Okay, so basically if I have plus 7 here and minus 2 here, okay, why is it minus 2? Oh, excuse me, chat. Apologies. That was a typo. It's got to be plus 2 because the manganese. Okay, if we would have gotten that, you would have gotten that correct. So it would have been 9, but now we got it. Now based on that, apologies, chat. Based on that, what would it be here on the left now? Okay, so what would it be here on the left to make that balanced here? Plus, it's going to be on the left. All right, so it's going to be on the left. There we go. Now we're going to add plus 5 electrons here on the left, okay? So I'm going to add 5 electrons here on my final reaction here, okay? So this is my first reaction here. This is my first half of that redox. So y'all are cooking that up. So any questions here? If this made sense so far, go ahead and drop that thumbs up emoji if this is making sense so far, okay? And if you're getting a little bit lost, go ahead and drop that crying emoji or a pot emoji to let me know that you're cooked here. Okay, so we got 5 electrons. Let's see what we did. We got 5 electrons plus 8H plus MnO4 minus yields Mn2 plus 4H2O. Thank you, Luna. Luna says thumbs up. Wait, why 5 and not 9? Because I accidentally made a minus 2 here as a typo, but then I quickly changed that to a plus 2. Okay, Leslie's getting a little bit cooked. So Leslie, we're basically doing balancing our redox. And so the first thing we did was we balanced the oxidation numbers. Okay, so that's how we got minus 8 plus 7. And then on the right hand side, we saw that we had Mn2 plus. So the very first thing we did was add water. So I needed 4 oxygens, and so I added 4 waters because water is H2O and I'm allowed to add water, okay, because this is in solution. And then I saw we had 8 H's on the left hand side. So 8 H's gave me 8 H pluses on the left hand side. And then the last thing I did was balance the charge here to have an overall balanced half reaction. Okay, cool. We definitely got you on mole conversion, but right now we got to do redox. Great, so that's our first half. Now we got to do the exact same thing on the second half. It's going to be Fe2 plus to Fe3 plus. Now, this one's not going to be as hard because we already have everything without oxygen. So what do I got to do to balance on this side here, chat? What do I got to do to balance on the right-hand side here? So let me pull up a poll here. Let me pull up a poll. So am I going to add... Am I going to add an electron to the left or to the right? We're going to do a quick poll. So am I going to add an electron to the left or to the right? So make sure you vote in the poll. It's going to pull up in a few seconds. We got to balance Fe2 plus yields Fe3 plus. Let me erase this. That's an Fe3 plus. Okay, we got a quick poll up on the chat. All right, 60 seconds on the clock starting right about now. So we have Fe2 plus yields Fe3 plus. So make sure you tap on the top left hand side of your screen and vote in the poll chat. So are we going to add an electron to the left hand side or to the right hand side here to balance out this reaction here, Fe2 plus and Fe3 plus? Okay, my pleasure, Leslie. Add an electron to the right. Shady says right. User says crying. Luna says crying. User says right. Log says crying. Okay, we got 4 for the right. We got 4 for the right. Let's see if you're right. Haha. 30 seconds left. Okay, we got 5 people saying add it to the right here. So let's go ahead and jump the gun here. Let's just make sure, okay, that if we add an electron to the right, that's going to have an overall minus charge. So there we go. So we're going to have plus 2 equals, that's plus 3 minus 1. So plus 2 equals plus 2. Perfect. Perfect. So 5 seconds left. 3 seconds left. All right, everyone cooked that up. We got 5 correct answers for 1 electron on the right-hand side. So that's why we added 1 electron on the right-hand side for this redox reaction here. And then the next thing we have to do is balance out our total number of Fe's here. So if I got to combine these, I have to have 5 electrons on the left because I want to cancel those out. And I only have 1 electron here. So I'm going to multiply by a 5 here, chat. So again, I have a 5 here on the left-hand side. Okay, I have 5 electrons here on the left. And then I only have 1 on the right here. So I'm going to multiply this by 5. Okay? All right, great. So now all we have to do is add up those 2 half reactions. So I'm going to add up this reaction and this reaction. So let's add that together. So I basically have 5, that's an E by the way, 5 electrons. Cool, so 5 electrons plus 8H plus MnO4 minus, that's the first reaction. And now I have 5 Fe, I have 5 Fe2 plus, okay, I'm just adding up those reactions here. And that's gonna give me Mn2 plus 4H2O, okay, and then plus 5 Fe3 plus and 5 electrons. All right, so let's take another pause here. So does everyone understand how I got this reaction here? This is the overall redox reaction here. So everyone's so far so good here. Let's see those thumbs ups, okay? And if you got a little bit cooked, just let me know what can I help clarify here, okay? So again, this was my overall. Let's make this a nice yellow color. I'm gonna make this a nice yellow color. So this reaction is right over here, okay? And right over here, okay? And then this reaction is down over here. I'm gonna make this a nice purple color, okay? So that's why I did that. Okay, so what's the next step here? Okay, Leslie's getting that crying emoji, okay? Oh, so sometimes it can't show the whole thing, which is strange because it's showing me that you guys can see the whole thing. So let's zoom out like this. Maybe that's causing some confusion here. Okay, but hopefully it's not too small now. How is that, my friends? How is that? Is that going to be making a little bit more clear here? We got to wrap it up quickly because I'm running out of time today. So our overall reaction here is 5 electrons plus 8H plus MnO4 minus, which again came from that first reaction, plus 5E plus Fe2 plus, okay, which came from that second reaction, equals, now we have Mn2 plus and 4H2O, so I'm going to just bring that down over here, and then plus Fe3 plus and 5 electrons. Okay, once again, this is a little bit on the college level, so if you don't quite get it and you're not in college, that's perfectly fine. And now I'm going to cancel out, well, I have 5 electrons on the left and 5 on the right. Okay, and so I can cancel out those 5 electrons. Okay, so at the end of the day, that's pretty much going to give me my final balanced equation here. Okay, I just have to put that in one more time. Let's see if I have my 8H pluses here. Okay, and that's going to give me, again, my... okay, I'm going to just start with my 8H plus MnO4 minus plus 5Fe2 plus, and that's going to yield Mn2 plus 4H2O and Fe3 plus. Okay, super long reaction, but hopefully you're able to follow along and see how redox kind of works. Okay, maybe next time I'll start with some easier examples so we can do the balancing a little bit later. Okay, but that's going to be our final example. Noah, I'd love to do Orgo, but unfortunately I'm running out of time here. I'm going to be on for about 5 more minutes here. Let me know if this was helpful, chat. Happy Halloween. Just bought my costume. Ooh, what'd you get? What are you going to be? Chat, what are you guys going to be? Speaking of which, I got to do a reveal because I got my little fit as well. If I have them here. Let's see if they're here. Okay, it's on my story. It's on my story. It's fine. All right. Cool, guys. So pretty much gonna end it right soon here. Hope this was helpful. I will be posting this tonight if you want to review. This was just a quick example on redox. My family is doing inside out. Ooh, I'm going as discussed. Ooh, inside out. For the Fe3 plus, is it not 5 Fe3 plus on the right? Oh no, this should be a 5 on the right here. Yep, that's a 5. Apologies, chat. Okay, for that typo, that's 5. Thank you for catching that. Let's rewrite that. That's 5 Fe3 plus on the right hand side. Okay, 5 Fe3 plus on the right. There we go. And that is indeed the correct answer there. Okay, awesome, chat. Thank you for that clarification. And awesome, guys. So just a quick little live stream for today. Pretty much gonna end it here. Guys, let me know how the semester is going for y'all. Y'all already know you can sign up for tutoring by tapping that link in bio, engineeringminds.co. I will be having office hours in the Discord tomorrow, so if you're in the Discord, you can join in, ask questions one-on-one. And yeah, we'll just be back on the next live stream. Do you think you can do a quick example of finding the charges when it's a 3 elements together? Do you think you do a quick example of finding the charges when it's 3 elements together? If we have, let's see, I mean, if I have one here. If not, can you join on the Discord? Okay, if anything, can you join in on the Discord? Because we're gonna have, for instance, AGCN. So you can drop that in the Discord, and I'll just get back to you later. Okay, because I need to see what you're talking about. And you see what you're talking about, Alex. Okay. So yeah, guys, pretty much gonna end it for today. Thanks so much for joining. Charlie, good to see you. And yeah, guys, thank you for the heart me, El Compass, and yeah, guys. So once again, if you need any tutoring, I got you for those STEM subjects that I mentioned earlier. Got you for math, Gen Chem, physics, and calculus. And so yeah, sign up for a free consultation call. Sign up for the Discord. It's totally free. So just tap that link that says Discord. Okay. Yeah, Peter says you just need to memorize your polyatomic ions. All right. And cool, my friends. Next week, I'm going to try to be on a little bit longer, but I do have to end it now. So thanks a lot for joining, and I'll see you for the next live stream. We'll be on Monday. Ooh, we'll be in a new month by then. So I'll see you all next Monday at 6 o'clock PST, 9 o'clock EST. Thank you, everyone, and have a great rest of your evening. My office hours are going to be tomorrow in the Discord at about 12 or 12:30. I'm going to make an announcement tomorrow. All right? And that way you can interact one-on-one. All right, good night, my friends. Have a safe Halloween weekend if you celebrate Halloween. And peace out, my friends. Have a great rest of your night.